By the way,
Yeah.
I didn't get my math assignment in the mail. Should be
And
coming today.
morning.
Tira, yes. I sent it to you and the other two students, but I was late. I sent it on Friday. So you'll probably get it today, hopefully. And if not today, then tomorrow. And I'm not going to hold that assignment against you guys until you get it received, okay?
Okay.
So that was, let's see if I can remember. Was it Victor and Tira and then Lauren? You three should be getting it like probably today in the mail.
Okay.
Okay, thank you.
Totally. And remember, you can use what we did last week. The video's up. So either you copied it down as we went or you can just review that video. Philman, how's it going today?
Good. How are you?
Good, good.
So we have to finish the master test like 1 to 6.
Yes, sir. Yep. Yeah, I want you, everyone, if you haven't already, you should have gone through and done all the assignments for Unit 1. Today, we're going to review the unit together. Tomorrow, we're going to take the test as a group.
Okay.
So, take those mastery tests. And we also did the online worksheet on what went last week, Wednesday and Thursday. It took us kind of 2 days. So videos are up for that if you need to review it and see how we did it, how to access it. Use those videos or also message me. You can get me on Google Chat. Some of you have already been doing that, so awesome. Thank you for messaging me on Google Chat, or you can add me on Remind. I've sent you several emails with instructions on how to add Remind. If no one's done that yet, or if you want help on how to do it, just let me know.
Your turn.
All right, so now it's almost 11:05. Let's get cracking. So everybody, we're going to be doing a unit review. I'm going to show you different problems from Unit 1, and it's all modeled straight off of the test. So everything you see with me today is going to be a copy, basically, of test questions for tomorrow with just some numbers changed. Everything should look familiar, nothing new. It's all stuff we did in Unit 1. Here we go. Okay, so I wanted to start off with complex one. Copy this down. Simplify the expression. 2 times 4/5 x plus 1 minus 3 times 5/3 minus 7/6 x. Now, just in case anyone's worried, there are easier problems than this on the test and today. But I just made them in the same order that you'll see them tomorrow. So even though this one's kind of scary with all the fractions and the adding and the multiplying, you can do it. Let's review how to do it together. So copy this down and then we'll start it together. Now remember, for the 2 times and the 3 times, we can multiply numbers to fractions without having to make them the same denominator. It's adding or subtracting fractions where they have to have the same denominator. So we have to distribute 2 times the first term and then 2 times the 1. And then we're going to do the same thing with a -3. So -3 times the first fraction and -3 times the second fraction. And then we'll try to add the fractions together. So to do the multiplying, and believe it or not, the multiplying is the easier part, I think, than just like adding the fractions together. When we're multiplying, just multiply the whole number to the top number in the fraction. So 2 times 4/5 is like 2 times 4. 8 fifths. So we have 8 fifths x, and then 2 times 1, that's just plus 2. And that's our first simplifying. That's 2 times just the first parentheses. Now let's do negative 3 times its parentheses. So negative 3 times 5 thirds. Negative 3 times 5, that's 15, over 3, 15 thirds. And now negative 3 times negative 7/6 x. Negative times negative, that makes it positive. 3 times 7, 21, and that's over 6. And there's an x there. It has an x on this number. So now the multiplying is all done. Now what we need to do is actually add the fractions in whole numbers. Let's see if we can simplify any of the fractions first. So 8 over 5, 8 fifths. We can't divide out 5 from top and bottom, and we can't divide out like a 2 from 5, right? So we can't simplify 8 fifths. But if you look at negative 15 over 3, that actually simplifies pretty nicely. 15 divided by 3 comes out to 5. So if I copy down what I've got so far, and all we did was do 15 divided by 3, that just turns into a negative 5. So that got rid of one of the fractions. So that's nice. Always look for that. 21 over 6, if you try dividing that, we get a decimal. So I don't think we'll be able to divide that one. But if you try dividing out 2 from both, that doesn't work. But if you try dividing out 3 from both, like this, so we're reducing the fraction, dividing by 3 on top and bottom, then that actually does change it to 7 over 2x. Oh, and let's combine our 2 minus 5. So that would be what? That would be minus 3. And then we've got plus 7 halves x. Okay, so far all we've done is simplify the fractions a little bit. And we combined 2 minus 5 for that negative 3. I'm going to stop real quick. Any questions so far? Concerns?
So we had to simplify to the minor number.
I'm sorry. Can you ask again? I didn't quite hear.
We had to take into the minor number, like to simplify.
You mean for which part? Which simplifying are you referring to?
I mean, what's the real answer?
Oh, the final answer?
Yes.
Okay, sorry. You know what? We're not there yet. Because I can add 8 fifths x and 7 halves x, 7 over 2x, but we've got to make them have the same denominator first. So think back to our first week when we were adding and subtracting fractions to each other. So 8 fifths x plus 7 halves x. Side work here on the right, if I want to add these two fractions, remember they both have to have either a 5 or a 2 or some other number as a denominator. They have to have a matching denominator. So we're going to multiply the first fraction by 2 over 2. And where did I get the 2 from? It's the second fraction's denominator. And the second fraction will get multiplied by 5 over 5. Let's see what we get. On the left, we have 2 times 8. That's 16 tenths. And on the right, it's 7 times 5, 35. Double check me. 35 tenths. And now they have a matching denominator, right? So we can do 16 plus 35 tenths. And what is that? That'll be 45, 51, I think. Excuse me. Double check me. Those of you with your calculators and phones ready. I think that's 51 over 10, 51 tenths. Now, these were fractions with x, right? They had an x variable each time. So don't forget to apply that. I'm just doing side work here, but imagine if they had x's this whole time. So I'm going to kind of put those in so I don't forget about it. 51 over 10x. Now we've done our adding of the two fractions. So our answer, 51 10x minus 3. And there's our answer. Final answer. So I won't lie to you, that's a tough problem because there's a lot going on, and it started with multiplying a whole number into a bunch of parentheses, and then we had to add fractions together.
So, but the goal is to simplify to the minor number.
Yes, sir. Yeah, the goal is to simplify and what does simplifying mean for us? It means adding all the like terms that you can. And that's what we did. We wanted to get rid of these parentheses. So we multiplied those numbers through, and then we tried to add together our like terms. So our 8/5 x and our 21/6 x, we were able to add those together, and our 15 over 3 turned into a whole number, so we could add that to 2. To the smallest minor number that we could for everything. Any other questions, concerns, please?
No.
Okay. I'm going to wait like 8 seconds if people are still copying down, and then we'll look at number 2.
Oh, actually, I have one question.
Go for it, Tira.
So, what all these problems that you're showing us, would it be on the practice test or the actual test?
The actual test.
Oh, okay.
Yeah.
And it would be like, I mean, probably not the same numbers, but like the same format?
Exact same format. I changed the numbers. I made sure everything I changed works. So our examples will make sense today. But they're basically test questions that I just changed the numbers for.
Okay, cool.
And this question we started with, as rough and tough as it was, is on our test with different numbers. Yep.
Okay.
Okay. I'm going to move on and try number 2 with you. And I personally think this question is a lot easier and a lot easier to start than the last one we did. What is the value of the expression when c is equal to 2, or I'm sorry, negative 2, and d is equal to 6? And then below we have an expression, 1/2 times c to the third power plus d to the second power. This is an example from our first 2 days when we were doing a lot of different review topics, and one of them was evaluating expressions. And that means simplify after plugging in a value for c and d. So if we start by plugging in our negative 2 and our 6 for c and d, that'll look like this. We have 1/2 times the parentheses, and inside those parentheses, I'm going to switch out negative 2 for C, and then a 6 for D. Now, because one of the numbers, C and D, was negative, the C, I'm going to use a parentheses with that just to be safe, okay? Because it can matter when we're doing squaring or third power or fourth power like we are here. So remember, what any number to an exponent means is it's multiplied to itself the exponent number of times. So side work here, let's really quick examine what negative 2 to the third power means. Well, that means negative 2 times itself 3 times, like this. negative 2 times negative 2 times negative 2. Now you can do this in your calculator, or if you do it by hand, this is how we would write it. 2 times 2 times 2 should give us 8. And what happens when if you multiply negative times a negative times a negative, like we are here? Remember, negative times a negative, just these first two, cross out or become pluses. Remember, a negative times a negative makes a positive, but there's one leftover negative. So that means our answer is negative 8. And that's just the negative 2 to the third power, negative 8. Now I've got 6 to the second power. So 6 squared is equal to 6 times 6, 36. So in my parentheses, we've got negative 8 plus 36. Now, folks, you could do your distribution, right? We could distribute a half. So a half times negative 8 and a half times 36. But we can also simplify the inside of our parentheses now. We can add these two numbers together. Let's do that. So negative 8 plus 36, what'll that be? 28? Someone double check me, please. And now we multiply our half to 28. 28 over 2. And if you try dividing that, we should get a nice clean answer, 14. There's our answer, 14.
We're subtracting 8 and 36 because it's a negative plus a positive, right?
Exactly. Very good.
Okay.
Exactly. The identity of that 8 is negative because it's got a negative sign. So whether you write it the way it's written here, I'll do some side work, negative 8 plus 36, that's how it's written. But like Tiara said, it's completely right on if you wanted to move those. But if you move them, keep the negative with whatever started off negative. So it's 36 minus 8. And these mean the same thing as each other. We're basically just subtracting 8, like she said.
Okay, cool. And then, sorry to interrupt.
Go ahead.
Would it be 28? I can't really see. Would it be 28 over 2?
Exactly.
Okay.
28 over 2. And you see how I got that? By multiplying the half times the whole number 28.
Right. Okay.
Okay. Very good. And then it turned out that we got a nice clean answer. It doesn't always happen that way, right, with fractions, but sometimes they divide evenly. 28 divided by 2 gave me the 14. Any other questions on number 2? Okay, let's look at number 3, and I'll wait for people to copy down. Example 3, what is the value of the expression when g is equal to negative 4.5? And what's our expression? 5 minus, and now these bars, folks, are absolute value bars. We talked about this the first week, absolute value bars. Absolute value of 2 times g minus 10. So step 1 is plug in the number for g, and then we basically are just using order of operations to simplify and whittle it down to, like I think what Victor said earlier, the most minor answer as possible, the smallest looking answer that we can. So that just means combining like terms. So let's plug in our g. Here's my absolute value. I've got 2 times g. That'll turn into 2 times negative. Put in parentheses there to make sure that you don't subtract it. Remember, we want to multiply 2 times g. So negative 4.5 minus 10. Okay, now inside our absolute value, let's try to whittle that down to as small a number as possible. And then we'll take the absolute value. So 2 times 4.5. Someone do that for me, would you? 2 times 4.5 in your calculator.
I got 9.
Good, thank you. And notice that out of 2 and negative 4.5. One of those is negative, so that'll be a negative 9. Then we still have our minus 10. So far, we've just done the multiplying. Now we've got to combine negative 9 minus 10. So off to the side here, negative 9 minus 10. This time, both numbers have a negative identity. So they're going to dig deeper down into the negatives. Negative 19. Remember, if they were both positive, they would stack up higher into the positive land, right? But now they're both negative, so they're digging deeper down into negative land, negative 19. So we have 5 minus the absolute value of negative 19. Okay, absolute value means whatever's inside that box, when you have it down to a single number, like we have it now, we're going to make it positive and drop the bars. So we have 5 minus, because of this minus here, a positive 19. But because it was already 5 minus the bars, it's 5 minus 19. So 5 minus 19, if we try that in our calculators, the difference between 5 and 19 is 14. And which one's bigger? To start with, the 19 is bigger, right? So that means there's leftover negative because the 19 was negative. So our answer, negative 14. I just realized that's really close to the answer for number 2. That wasn't on purpose. Just an oversight. Negative 14. Any questions on number 3? Anyone need more time on number 3 before I move on to the next question? Please. No. Okay. Remember, please jump in and interrupt me. If you have a question, I want to hear from you. Let's try number 4. Simplify the expression. 5 times a parentheses plus another parentheses. So we want to do our multiplying and then try to combine any like terms that we have. So 5 needs to be multiplied to everything inside its parentheses. 5 times 2, 5 times negative 3x. So 5 times 2 gives us 10. 5 times negative 3x, negative 15x. And after we've done the multiplication, we can drop the parentheses. We don't need them anymore. And because there's nothing being multiplied to the next one, there's no number there for 4x minus 12, we're just going to drop those right now. And now scan through your problem and combine like terms. So the whole numbers, 10 and negative 12. Off to the side, I'm thinking 10 minus 12. The space between 10 and 12 is 2. Which one's bigger? The 12 is bigger than 2, so there's leftover negatives because the 12 was negative. So I combine my 10 minus 12 into a negative 2. Now for my negative 15x plus 4x. So to the side, negative 15 plus 4. Space between 15 and 4 is 11. And again, the 15 is bigger and it's negative, so it's negative 11x left over. Remember, those were the x numbers, so don't lose that x in your answer, negative 11x. And that's it. I can't add 2 or negative 2 to an x number, right? Not like terms, so we're done here. I'm going to wait a few moments. Any questions? Okay. Number 5. Now this one might look a little scary at first, but if you scan through the problem, notice that it's all a bunch of whole numbers without any x's or variables at all. This, even though it's a bigger problem, is really just an order of operations problem. So, and remember, we want to use order of operations all the time. But really, that's all this question is testing us on. I'll write down the order of operations, PEMDAS. So parentheses, exponents, multiply, divide, add, subtract. So let's try to do our parentheses first, meaning the work inside the parentheses first. So I see 3 minus 4, and I see 20 divided by 10. So let's do those and copy down everything else. So 3 minus 4 is negative 1. And then 20 divided by 10 gives us 2. 20 divided by 10. Okay, so parentheses are done. Now we want to do exponents, and there is an exponent here. Negative 1 to the second power. Second power means whatever the base is, in this case it's negative 1, it's that times itself 2 times. So negative times a negative is positive. 1 times 1 is 1, so this is positive 1. So we have 9 plus 1 plus 3 times 2. So let's do that multiplication. So 3 times 2 is 6. 9 plus 1 plus 6. And I think that's going to be 16, but double check me. 9 plus 1 is 10, and then 10 plus 6 is 16. Okay. Any questions, concerns, please, on any of the previous examples, 1 through 5?
None for me.
Okay. Thanks, Levi. I just want to make sure I'm not. Oh, go ahead.
Oh no, I said none for me either.
Okay. Thanks, Tira. Thanks, both of you. I just don't want to leave anyone behind. If you want to go over another one, just let me know. Let's try number 6. Okay, this was a fun one. It's really just, I'm sure no one's thinking it's a fun one except me, right? This is just a vocabulary question. So, very first day, we talked about parts of an expression. We want to identify, using this expression that they gave us, 10x to the second power plus 3x minus 8. We want to identify the constant, the variable, and the coefficient or coefficients if there's more than one. Can anyone, will anyone be willing to try this one out? Can you identify the constant from the expression, or a variable, or any coefficients that you see? Anyone want to give this a shot?
8 is a constant.
High five. Thank you. Yeah. The
Wouldn't
8.
the variable? Oh, sorry.
No. Go ahead.
Oh, wouldn't the variables be x?
Yes.
Okay.
No other letters in this one, right? So x is our only variable. One other thing I want to quickly mention is that the sign kind of goes with it. So for the constant, I'm going to call that negative 8 because it was minus 8 in the problem. So remember, the negative is, or the minus sign, is part of its identity. Just in case that happens on tomorrow's test, make sure to bring that sign with the number. Coefficient. Anyone remember what a coefficient is?
10x to the second, 3x.
Yes. And it's just, very good. Thank you. It's just the number portion. So it's just the 10 and just the 3. Those are the coefficients. So I'll list them both here, 10 and 3. Those are both our coefficients. Any questions on this example? See, they're not all getting harder as we continue. There's some in the test tomorrow and in today's review that are, kind of goes up and down in how hard the question is or how long it might take to solve it. This was a pretty fast one, just a vocab question. All right, let's look at number 7. Okay, now for this one, it's a word problem. This was like our 3rd and 4th day of class, I think. Don't write the whole thing down. I want you to take a picture with your phones or a screenshot if you want to refer back to this later. Otherwise, just follow along with me while we solve it. I'm going to move this thing out of the way. Actually, I'll keep it there for now. So what I would encourage everyone to do, if you're ever given a word problem, read through the whole thing first, and then you're going to read through it again and try to identify any parts that look important to you or sound important to you, which means any parts with numbers or anything that we can make an equation out of. And let's do that now. So I'm going to read it, and then we're going to read it again and try to identify the important stuff. A machine cuts a strip of carpet into 2 pieces. The length of the smaller piece is 6 meters, greater than 1/3 the length of the larger piece. If the length of the smaller piece is 10 meters, the length of the bigger piece is blank meters, and the total length of the carpet is blank meters. So, starting from the beginning, a machine cuts a strip of carpet into 2 pieces. And we know that one's bigger than the other. We're calling one the smaller piece and one the larger piece. So if I were to try to draw this out, here's our strip of carpet, right? And we're cutting it, but not in half. One's bigger and one's smaller. So I'm going to kind of show that happening here. Here's our small, and here's our bigger or larger piece. Now, the sentence says the length of the smaller piece is 6 meters greater than 1/3 the length of the larger piece. This sentence can be turned into an equation. Let's read it again. The length of small piece is, remember, is means equals. So I'm going to put that above it. So this says smaller, or length of smaller. Smaller equals 6 greater is code for plus or adding. 6 plus 1/3 the length of the larger. So 1/3, 1/3 times larger. I'll write that below. Small equals 6 plus 1/3 larger. Now remember, small and larger, those are basically our variables. So I'm writing it out the whole word, but you could write it as just S and L, or any variables you choose. All right, and then they say at the end, if the length of the small piece is 10 meters. So now they've given us a number to plug in for small. Small equals is 10. Let's try to figure out the length of the bigger piece and then the length of the whole carpet before it was cut. So if I plug in 10 for small, we have 10 equals 6 plus 1/3 larger. So now we've got to solve an equation, and here's where we're going to isolate the variable. We want to isolate larger. We're trying to solve this for how big is the larger piece. So what's happening to the variable larger? And do the opposite of those things. I want to get rid of this plus 6. So we're going to minus 6 from both sides. So we've got 4 equals 1/3 times larger. Now, to undo that 1/3, we're going to multiply a 3 to both sides, because 3 over 3 cancels out. So what are we left with? We've got 3 times 4, so 12 equals larger. So that's part of our answer. We know that the length of larger or bigger piece is 12. And now we can find the final answer by adding them together. We know that small was 10 meters and the larger is 12. So we add them together for 22 meters. Now, this is a tricky one, I grant you, for sure. But tomorrow's will be just like this one with different numbers. So I want you to do your best to build the equation like we did here. It always can be helpful to draw a picture, however it makes sense to you based on how you're reading it, like I did here, to kind of figure out what these things are that I'm dealing with. And then we plug in what it says the small piece is and work to find the large piece. Any questions or concerns on this problem? No. Anyone need more time on it before we move on?
Where the 22 come?
Good question. Where did 22 come from? Let's double check what the 22 stands for. Reading in the sentence, it says, and the total length of the carpet, meaning like before it was cut. So they told us here, if the length of the smaller piece is 10 meters, so small equals 10, they told us that one. And then we solved to find 12 for the larger. We added 10 plus 12 to get 22. Does that help or not yet?
Yeah, that makes sense.
Thank you for asking. Any other questions right now? Okay, let's try another one. Okay, now this one is another word problem, and you probably saw one of these in your mastery test. So let's read through it. The sum of 2 consecutive numbers is 81. This equation, where n is the first number, represents the situation. And then they give us an equation, 2n plus 1 equals 81. What is the first number? So what they mean is that the sum of 2 consecutive numbers. What does consecutive mean? Consecutive means numbers that come right after the other. So for example, 1 and 2 are consecutive. 3 and 4 are consecutive. And also, any numbers on the number line that come right after the next are consecutive. So some other examples would be like 10 and 11, 140 and 141. So there could be like an infinite number of possibilities to what our answer is, but we have some information. We know that the sum of the 2 consecutive numbers is 81. That means if we knew the 2 numbers and we added them, it would make an 81. Then they give us this equation. They're saying n is the first number. Represents the situation. And then they're asking us, what is the first number? So basically, all we need to do in this case is solve for n. We want to know what is n, because they're asking us what is the first number. And they said above that the first number is n. So what is n? Solve this equation they gave us for n. So there really wasn't any building we had to do in this example, but we had to figure out what's going on and then try to, answer that question. So let's try to answer that question. 2n plus 1 is 81. Solve backwards to undo the actions that are happening to n. So we need to divide both sides by 2 and subtract both sides by 1 to cancel out the stuff happening to n. So we're going to do a minus 1 to start with. So 2n is equal to 80. And then we want to undo that times 2. So we'll do a divide 2 on both sides. And we get n is equal to 40. That's our answer. We found the first number. Let's really quick just check our work and see if 40 plus the consecutive number after it, 41, does that add up to 81? So I'm just going to check it over here. 40 plus the one after it, because remember they're saying the sum of two consecutive numbers. So 40 plus 41, if we test that in our calculators or by hand, we do get 81. It's like 80 plus 1, 40 and 40. So that worked. Again, I changed this question a little bit, but it's the same exact type of question you'll see tomorrow. Any questions, concerns?
Yeah. Can I get more time to write it down?
Of course.
Okay.
Of course.
Can you also check your work by just plugging in the answer you found
Who's-
in the problem?
Who's asking? I'm just excited. That's all. Anaya? Yes, totally. I love that question. Sorry, I didn't mean to scare you by yelling who's asking. I probably did scare you a little bit. Yes, absolutely. Plug it in. Let's try that. I'll change my color so it doesn't get too confusing with what I've already written. So take the 40. We found n equals 40. Let's take that 40 and plug it in back at the top. 2 times 40 plus 1 equals 81. I'm sorry, Anaya. I shouldn't have yelled at you, who's asking. What a dumb thing for me to say. I was just so excited. 2 times 40 is 80. 80 plus 1. Yep, it looks like it's working. It comes out to 81 equals 81. Yay. Whenever we have an equation and we're solving it for n or x or any variable, I love it. Please, at the end, plug your answer back in for the variable at the beginning and see if it balances. See if you get 81 equals 81. Absolutely. Good question. Any other questions or concerns on this or any other examples? I'll try not to yell with excitement about your question. Does anyone need more time on this one? Okay, let's try the next. Number 9. Okay. This one I actually pulled. I don't remember if I took this from the practice or from the actual test. I think it's from the practice. But there's a question just like this on the actual test. So what does this say? The given equation has been solved in the table. So if we look at our table here, they've got steps, step 1, step 2, step 3, step 4, step 5. And if you look in the statement area, we have an equation at the top, and then it looks like they're solving it one step at a time, moving down. And at the end, they get x equals -4. So what we're looking at is an equation at the top, and they solved it, and they got x equals -4. What are we supposed to do with this? Use the table to complete each statement. In step 2, the something property of equality was applied, and then in step 4, another property of equality was applied. So let's focus on step 2 and step 4 and see which property of equality. In the drop downs, you're going to have addition, multiplication, subtraction, division, the 4 different operations. So in step 2, right here, what are they doing in step 2 compared to the one above it? Does anyone see what they're doing in step 2 that's happening on both sides of the equal sign? Oh, I cut you off. Anaya?
Sorry, adding 6.
Don't be sorry. Yes, correct. Adding 6. So the property of equality would be the addition property for step 2. Good, good. Now do the same thing in step 4 for me. What are they doing in step 4 that's the same on both sides?
Multiplying 4/3.
You got it. So that means it's the multiplication property of equality. So I think there's actually more than one on the test that are like this. So there'll be a couple opportunities to do a problem like this tomorrow where you're identifying what step was taken or what property of equality was taken. Just like this problem. Any questions on number 9? And again, I should have said this at the beginning. Don't try to copy the whole thing. I don't want you to spend your time on that. Just take a picture. For a big problem like this, just take a picture with your phone so that you're not copying the whole thing. I'm sorry. I should have said that earlier. Any questions, concerns? All right, let's try number 10. All right. They want us to create and solve a linear equation that represents the model where circles and a square are shown evenly balanced on a balance beam. I was telling you guys the last couple weeks that an equation is a balanced scales, and that this is exactly what I'm referring to. This left side of our balance beam equals the right side. So this square and 5 circles is equal to 7 circles. So how can we write an equation with actual math now that models this scenario? Any ideas? I put the multiple choice options in there, so you can look at those if you want. We'll call this A, B, C, and D. Anyone want to take a stab at this? Or just first thoughts on how we could start? We're just trying to pick an equation that matches with what we see in the model.
I think it would be C. And I say that because there's 7 on one side, and there's only 5 on the other side. So the block would have to be equal to at least 2 circles.
Totally. And I love how you explain that. That you said there's 5 circles on the left. You can count them out. And then there's 7 on the right. And if we look at our options, the A, B, C, and D, C is the only one that has a 5 on one side of the equals and a 7 on the other side of the equals. So it's a great starting place. Plus, or also, it has x plus 5. So that means our box, our square, the blue square, might stand in for x. X plus 5 circles equals, it's balanced to 7 circles. Levi, thank you so much. That was great.
You're welcome.
And then you solved it for x in your head, or with that logic at least, that the x or the block must stand for 2 circles. And that's kind of like our variable x. Good. There's at least one problem on the test tomorrow that looks just like this with a different like setup, circles and blocks, but it's just like this.
Josiah, I'm
Yeah.
gonna copy this down real quick.
Copy it down, and you feel free to take a picture of it if you like.
Actually, yeah, that's what I'm gonna do instead of copying it down.
It's a little faster, and I'm sorry to rush everybody. I don't mean to rush anybody, but some of these problems, I just know it's going to take a long time to copy. So I'm encouraging everyone, feel free to take pictures or screenshots for these ones that aren't fast to write. I'll wait 10 more seconds if anyone is copying or taking a picture. Okay. Let's look at number 11. Okay, fractions, equal sign, variable. Looks like we have an equation we'll probably have to solve. What value of p makes the equation true? Let's read this thing. Negative 4p plus 1/6 equals negative 1/3. So, like all of our equations, our linear equations, we want to get p all alone. We want to isolate the p. So, what I taught you guys to do, and I'm encouraging you to do, is identify what's happening to p, or the variable, and then we're going to undo those things we identified one at a time. So, I see negative 4 is being multiplied, so we'll have to divide everything by negative 4. And I see plus 1/6 is happening to the p. So we're going to do minus 1/6 to both sides to undo that. And also, it's best to start by undoing the adding or subtracting first. Let's start by undoing this plus 1/6. So I'm going to go minus 1/6 minus 1/6. I'm doing it to the left and the right of the equal sign. So on the left, 1/6 minus 1/6. Now that goes away, right? On purpose, by design, we did that. So we're left with negative 4p equals. Now on the right, we've got to deal with these fractions. We have negative 1/3 minus 1/6. Now, like earlier in example 1, we have to add or subtract some fractions, which means we have to make them match in their denominators. So we can multiply the 1/3 by 6/6 and the 1/6 by 3/3, and that'll give us matching denominators. However, there's a little shortcut we can use here, folks, and that's whenever one of the fractions could match up with the other fraction's denominator. You might notice that if I multiplied, I'll show you here, if I multiplied 2/2 to my first fraction, that will give me a 6 in the bottom. So this came up a couple times as a group last week, I think. We don't have to multiply both of the fractions if you can make one of them into the other one's denominator. So we can kind of save a little bit of work in this case. Any questions on what I'm doing with the 2/2 before I continue?
Yeah, so we're multiplying just 2/2 by to 1/3 just to save us some time.
Exactly correct. Yes.
Okay.
Exactly. And that doesn't always work. It only works when one of the numbers. So in this case, I'm looking at 3 and 6, right? 3 denominator, 6 denominator. And I notice, oh, I could change a 3 into a 6 by multiplying 2. That wouldn't have worked for us back in example 1. So we had to multiply both fractions.
Okay, cool.
Is that okay, Tira?
Yes.
Okay. So I'm running out of space. Sorry, let me move this thing up. And nice. So negative 4p is equal to negative 2/6. That's my multiplication. Minus 1/6. Okay, now we're ready. We've got matching denominators for 2/6 and 1/6. Notice they're both negative. So this is kind of asking us, this is asking us to combine the negative 2 and the negative 1, and then it's going to be out of sixths. So negative 2 minus 1, negative 3/6. Okay, I'm running out of space, so I'm going to continue here. Sorry about that. So we have negative 4p equals negative 3/6. Now, you might notice that 3/6 can reduce. How did I notice that? Just because I remembered over lots of practice that, well, for one, 3 goes into both of these numbers, but also 3/6 represents a half, right? 3 is half of 6. So what I'm doing is I'm dividing the top and bottom by 3. just to reduce my fraction. That's negative a half. Okay, now let's get back on track and get p all alone. So divide by whatever's being multiplied. We're going to divide by negative 4. And since I've already got a fraction bar on the right side with my half, I'm just dividing by negative 4 means I'm putting a negative 4 on the bottom of that fraction. It's basically dividing that side by negative 4. It just so happens that we already had a fraction there this time. So p is equal to 1 over 2 times 4, 8. It's going to be positive 1/8 because my negative is being divided by a negative. Negative and negative together, remember, makes it positive. So we got a fraction answer, but we're done. P is equal to 1 over 8. All right, I know we're really close to 12. I want to do one more with you before we get to 12 here. And hold on, don't drop off yet because I didn't take roll yet. So I hope those folks come back. Let's do one more together. All right. Order each step and justification that is needed to solve the equation below. So at first glance, this might look kind of scary, but once we kind of survey what's going on, it's not as bad as it might look at first. So we have an equation, steps, and it looks like they're solving it one step at a time. And then on the right, they're showing their like reasoning for it. And then in your test tomorrow, you're going to be clicking and dragging these options in the bottom in the gray area up into like their slots. So for the steps on the left side of the table, think of it as just solving the equation and showing each step at a time. Now we see that they added the 6x to both sides here and here. So let's combine like terms on the left and the right. So we would get 4x is equal to, these cancel, 28. And look at that down below. That's one of our options. So you would click this option and drag it up into that slot. And then what would you do next to solve this? You would divide both sides by 4. So that is what we're going to see down below as one of our options right here. That could be dragged and brought up as 4x over 4 equals 28 over 4. And then lastly, you would simplify, right? You would do the simplifying and get x equals 28 over 4, 7. And that's one of our options that we could click and drag up. Then we've got to add in our justifications. So when they added the plus 6 and plus 6, that was the addition property. And at the end, they're dividing 4, so the division property of equality. All right, let me really quick mark down you guys who are here. All right, Anaya, Betty and Barricade Brooke. Philmon, Levi Moose. Robel, Savannah, Tira. All right, Victor. There we go, Victor. All right, and I know that Lauren was here earlier, but I don't know who the second person is who left. Maybe it was Joseph. They left early. All right, folks. Thank you for your patience and for working along with me. I hope today was useful. You don't have to do the extra practice, Savannah, but it won't hurt if you want to just get extra practice. tomorrow we're going to do our test. So come back tomorrow. If you have time today, do your extra practice just to see what it's like. It's going to give you a mix of all the same types of problems that are on the test.
Teacher, I just want to take a pictures from the examples.
For the last one?
Number 2.
Okay.
No. Number 3 and 4 and 5.
Okay, just one sec.
I lost that one.
Totally. All right. Two.
3. Number 3.
Here's number 2. Did you get this one?
Yes, I get that
Okay.
one.
Number 3.
Number 3
Here's number 3.
and 4 and 5.
Sure. Here's 3. Here's 4.
I could go back to number 3.
Sure. Here's 3.
Okay, number 5.
And number 5.
There we go.
Anything else?
And just number 9.
Number 9. Okay. Here's number 9.
There you go.
Okay. Anything else?
No, that's it.
Okay. Thanks, Victor. Don't worry about the worksheet for now. You'll get it in the mail, hopefully today, maybe tomorrow. I'm not going to hold back your whole unit because of that, but when you get it, just do it and then share me the pictures, okay?
Yeah, and I have another question.
Yeah.
I didn't finish it all the unit 1, so anyways I can take the test.
Yeah, I want everyone to take the test with me tomorrow, even if you're behind on other mastery tests, because we'll have a chance to do the test together as a group. You can ask questions if you want to ask about number 3 or number 6 or whatever. I want to talk it through with you tomorrow, and that'll go for everybody.
Okay, and I have another question. We have a day to finish this class from math enrichment, I think.
So if you finish it late, let's say that a student doesn't have like some mastery test done and maybe a student doesn't pass the test on the first try tomorrow, you can still retest on it again. You can still finish your mastery tests later. But what that means is then you'll just get your unit a little later than the other students, or not you, but anybody. So
So yeah, I finish it a little late. It's okay? Or?
it's okay with me. The only issue is that then, you won't have it in when you want it maybe. Maybe a student wants it in right now, but you finish it a week late. Well, then that's when you would have it done as a week later, So
Okay.
it's okay. Yeah, it's not like you can never finish it and you have to just suck it up. No, you get to finish it late if you need to, of course.
Okay.
Does that make
Thank you.
sense, Victor? I'm sorry. Does that answer?
Yeah, of course. I just, I would like to know,
Yeah, of course.
how that works.
Yeah, no, you can totally finish late. I would prefer if people tried to finish it on time with me, but if you need to retest or finish something later, it's all good.
Okay.
Yeah.
That's good.
Yeah.
Because I get an momentum, but I don't see like a day to finish it. I just see like do it, but I don't
Totally.
see,
That's
like,
basically all I've said is just do it. Yeah. So
yeah.
try to get your mastery tests done today. And if you can't get them all done, then tomorrow I want you to do the rest. And Wednesday, do the rest. And eventually soon this week, hopefully, we'll have them all done.
Okay.
And Victor, you should come meet with me tomorrow at 3:00 if you can.
Okay, yes.
If we have extra